Hello everybody, welcome back to another TerrNav video. Today we're going to be talking about scent and drift with maneuvering boards. I know I said I wouldn't be back, but I'm back because I found a little bit of time to make this video for you guys. So there's 4 different types of problems you can encounter solving for different courses or speeds, and I'm going to go over the 4 basic types of problems that you can find. So starting with this one, and the first thing to know is that your course and speed made good always come out of the center, and your set and drift always come out of the center. Your course advanced and your speed advanced do not. Those come out of your set and drift. There's a saying, the current kicks you in the ass, and so the way you think about that is wherever that current vector ends, that's going to kick you, and so that's where your course advanced and speed advanced starts. Let's start. We know that the set and drift is 225 and 3 knots. Now, before I even do that, I want to make a point that we have the speed of advance of 12 knots here. 12 knots, this doesn't go out to 12, right? So we have to use the 2-to-1 scale. So a 12 becomes a 6, 3 becomes a 1.5, and so on. I know that my set and drift are 225 and 3 knots, so I'm going to find 225. 225 is here. And I find the corresponding one over here so that I can get a good alignment. And I'm going to line that up, and I'm going to draw a line out 1.5. So the outer ring of this, the center, that's 1, and then every plus is a half, so take it out to that plus there, so that'll be 1.5 right there. So that's my set and drift, and you got to make sure you label it with an arrow. We know our course advance and our speed advance, and remember what I said, that's going to come out of this. So our course advance is 090, speed of advance is 12 knots, so that means I'm going to go 090 from there. So line up my triangle, move it down to the end of that vector. And then I have to figure out what 6 knots is. 12 knots, which is really 6. So I can use the 2-to-1 scale over here and measure that out, or I can know that 6 times 2 is 12, so just take this out to 6. And then measure from the end of my vector there to 6. That puts me like here. So I know that I can just take this and draw it out to that line. That's 6. And you always want to make sure that you're labeling everything. So this would be set 225.0 degrees true, drift 3.0 knots. My handwriting sucks, but you get the idea. And then this is our course and speed advance, so COA 0.0 degrees true, SOA 12.0 knots. And then we know that our resultant vector has to be going this way, and that's going to be our course and speed made good. So I'm going to draw a line from the center of the scope to the end here. This is like the hardest part, the whole thing. Draw an arrow on that, label that CMG, SMG. And then now I gotta figure out what that angle is. So just like you would do on a chart, you can line this up here, and then you can move it to the center, drop it down, see where it goes, and that's looking like 101.9. So course made good, 101.9 degrees true. And it looks like the answer is 102.1, so you'd be absolutely in tolerance if you did that. And then our speed made good. Going to measure this distance, move it up to 2-to-1 scale over on the side, and we're looking like 10.3, and the answer was 10.1, so we're again close enough. So that's how you do this type of problem. So let's turn this over and we'll look at a different type of problem you can do. This time it's the same type of problem, except instead of drawing in the CMG SMG vector, we're just drawing in the COA SOA vector. So let's start with our set and drift again. So 045, 45 is here, 45 down here is there. And we know that because that SMG is 12 knots, we have to be on the 2-to-1 scale again, so everything's cut in half. So that 3 is really 1.5 here, and we're gonna go out 40, we're gonna go out 1.5. again. And then remember that our speed made good and our course made good come out of the center. So 090 at 12 is just 6. So I'm going to go out to 6 there. And then again, we just have to figure out what the resultant vector is. As they say, there's artwork in the chart work, so there's going to be tolerances on all this. Nobody's perfect. We're going to do the exact same thing here that we just did. So Remember, line this up, figuring out what that angle is, and we're looking like 102.1. So COA 102.1 is true. SOA, again, we're going to measure the length of that vector, and we're looking again like 10.1, 10.2. And again, close enough. The answer was 102.0 and 10.2, so we're pretty close. So that's the two I would call easy maneuvering board problems. So there's another type of maneuvering board problem where you're not solving for a COA and SOA or CMG and SMG, you're solving for a COA and SMG or the reverse. So in this situation, we know that the set and drift is 0.45, 3 knots. Again, we're using 2-to-1 scale because this 12 knots here prevents me from using the 1-to-1 scale. So let's set this up first, and I can kind of explain it as we go. So 0.45 again, and we're gonna go out 1.5. We know that my course made good is 0.90, so that means that coming out of here, I'm going 0.90 this direction at some speed. I don't know what that speed is, but I know that I can just draw a straight line from here, and I'm gonna be somewhere on that line in terms of speed. So we're gonna draw a straight line, and I know that my speed of advance, which remember comes out of the set and drift vector, is 12 knots. So that means that from here to somewhere on here is going to be 6 units because 12 knots equates to 6 units. So what I can do is I can take my point to pencil dividers, set them for 12 knots, and then I'm going to swing an arc from here down to here. And so I know that that's where the course of advance, speed of advance vector is going to intersect my course made good, speed made good vector. So I can erase this excess stuff over here because I don't need that. And now I'm just going to draw on that vector. Okay, so now all I got to do is find the length of this vector and the angle of this vector, and then I know the two things that I need to know. So easiest thing to do here would be find the length of this vector, so let's do that first. We're looking like 13.9, answer was 14, so we're pretty close. And then I gotta figure out what this angle is, and we're looking like 100 pretty much on the dot. Okay, so we got one final type of problem here that we can encounter, and that's where we're given our advance and made good stuff, and we have to find our set and drift. This is probably the hardest type of problem you can have. Again, seeing that 16 knots tells me that we're definitely on the 2-to-1 scale here, on the 18 too. So let's start with our course and speed made good, because that's going to come out of our scope. So we're 305 at 16 knots. So let me find 305, and its corresponding one down here. So 305, and I have to go out, because I'm going 16 knots, I have to go out to 8, which is over here. And then I know that my course of advance is 315, and so I'm going to have something that's 315 that intersects here. And then the difference over here is going to be my set and drift. So let's figure out 315. So 315 is here, and 310, 15 is there. And now we're just going to move this over to the end of that. And it's 8 knots, which is really 9 on the 1-to-1 scale. So I have to again use my point to pencil dividers to figure out how far I need to draw my vector. So now I just got to figure out this distance and this angle. So let's draw a little line here. And these are the ones that are going to have the highest error because it's very hard to get everything perfect. It's looking like 184.5. Now the answer on this was 186.1. Usually it's a tolerance of about 3 degrees, so you'd be okay. I probably did this faster than I should have. I'm doing it quick just for the purposes of demonstration, but if you do it slow, and if I were to do this slow, I'd probably get a little bit more accurate there. And about, 3.7 knots. So that's it. Those are really the 4 types of maneuvering board with set and drift problems that you can encounter. I know I said this last time, but this is going to be the final TerrNav video of TerrNav 1. We'll see if I make any TerrNav 2 videos, but yeah, see ya.